Good morning, kids. It's Mr. Agee here, and we are going to look at Lesson 6 problem set in your green book. So this is the um, section that you're looking for right here, the Lesson 6 problem set. This is the end of our intro to division. It's 3 lessons long, and we'll continue to practice division as we go all year long, really. So let's get used to the terminology and the kind of thinking that we have to do to recognize when we're seeing division problems. Now, what you're going to find is that all of the problems on this first page are related to each other. So the first problem kind of sets the stage for the second problem, and the third problem depends on your understanding of the whole situation to solve. And then moving on, we get into a new story problem here on number 4, and another new problem on number 5. And then I get to experience the great joy of Eureka Math, where they try to confuse kids and try to help you by confusing you. Um, so I'll do my best to help you work through it, and if we have questions, we can spend a little time talking about it during our live session. But we are going to do both of these pages, Lesson 6 problem set, and I will continue to read to you, but I will remind you that the expectation is that you're working towards reading this on your own and understanding it on your own. And so I model my thinking, I model the reasoning, but I want you to start catching on to that so that you can do it by yourself. Okay, so in problem 1, we see a person, Rick. We're remembering, we don't really know Rick, so it can be anybody. It can be ourselves, someone we know. Puts 15 tennis balls into cans. Okay, so if you've ever seen how tennis balls are sold at like a sporting goods store, they're in cans. Each can holds 3 balls. Circle groups of 3 to show the balls in each can. Okay, so let's look down at what they're asking us. We got all these loose balls in kind of a random order, and Rick needs blank cans. So the cans seem like a natural grouping because it holds items. So I'd say the cans would represent the groups, and then the size of each group would be, in this sentence here, each can holds 3 balls. So the number of cans would be the number of groups, and the size of the group would be 3 balls, and the total would be 15. Now let's talk about the equation vocabulary. So we've talked about multiplication. The parts that you multiply together are called factors. So we've got one factor here times another factor here, and it equals a product. Okay, that vocabulary is important. Um, they will ask you to, at various times throughout this year, they'll ask you to find the product or use the product to do something or find a missing factor. So right here we've got a missing factor. And we already know that this factor represents the number of groups and this factor represents the size of the groups. And that's how, when you've got two factors, it's number of groups times size of each group. Now, looking at division, they are related. It's a related process, so they call them inverse operations, which means they're opposites. And so multiplication, where we have a missing factor, that can be the answer in a division problem, and that has a special name. It's called a quotient. It's a Q word, so the answer to a division problem is called a quotient. But when you rearrange it into a multiplication problem, it's a missing factor, okay? So here we've got the product is the total that we start with in division, the total number of tennis balls, and we're dividing them into groups of 3. So the size of the group is 3, and we're trying to find out how many groups is that? How many groups of 3 can we get when we have 15 total balls, okay? So they have you doing a visual model here where you're actually to do this verb right here, circle. Okay, that means with your pencil, you're actually going to draw a circle around three balls and then draw another circle around three balls and do it until you run out, and you shouldn't have any leftover tennis balls. Um, so at the end, what you're going to do is count how many circles you made. Each of those circles represents the number of cans or the number of groups. So you're going to count those circles and that you're going to write the same number three times. You're going to write the the number of cans here. You're going to write the number of cans here because you're finding the number of groups. That's what this missing factor is. And then you're going to find the number of cans here because that's what you're solving for when you divide 15 tennis balls into three groups, or I'm sorry, into three items per group, three balls per group. You find the number of groups, the number of cans. Now, in the next problem, they use the exact same numbers, okay? So they're helping you to make a connection. They're helping you to understand that when you know both factors and the product, you can flip them and it's the same, okay? It's called the commutative property. But it's important to know what the parts stand for. So they're really testing your knowledge of what does each factor represent, okay? And then how can I rearrange it into a division problem to say, okay, well, what does that quotient represent? Rick uses 15 tennis balls to make 5 equal groups. Okay, now they're telling us there are 5 equal groups. There are still 15 tennis balls. Draw, so this is your verb, draw. This is what they're telling you to show how many tennis balls are in each group. Okay, so you're going to draw 5 equal groups. We have some strategies for doing that. You could do an array, you could do a number bond, you could do 5 empty circles, and then you're going to fill them with 15 tennis balls, and they have to be, each group has to be equal. Okay, so you could use a distribution strategy. Um, you could use all of those pictures actually if you want to. But I'm going to tell you right now, if your answer down here doesn't have the same numbers in it as the answer up here, then you're doing something wrong. Okay? Because these problems are related problems, and it's basically a fact family. So they're showing you the different ways to put these numbers together. All right, next. Now it tells you to use an array to model problem one. Okay, what they really mean is draw an array. Okay, it says use an array. Well, I don't know what they expect from you with that verb use. What they really want you to do is draw an array to model problem one. So even if you drew an array here as your model, do it again down here, and they want you to make that connection. The problems are all the same. You see, the problems here are up in problem one, and the problems here are right here in problem two, but they take it a step further. They ask you, okay, what does the blank mean? What does the number that you're putting in this blank, what does it stand for? Okay, so just to review, we've got the basic parts of a multiplication problem are the number of groups, the size of each group, and the product. And in division, it's the total number of items divided by either the number of groups or the size of each group. Okay, so on these lines, you should have either the size of each group or the number of each group. And it's not both. One of them is the number of groups and one of them is the size of each group. Okay, moving on. Um, Dina, which is my mom's name, Dina makes 21 jars of tomato sauce. Okay, I've seen a jar of tomato sauce before. I'm visualizing that's a lot of jars of tomato sauce. Um, she puts 7 jars in each box. Okay, so her groups are boxes um, to sell at the market. How many boxes does Dina need? Okay, so we know the size of each group is right here, the size of each group, 7 jars in each box. What we need to know is the number of groups. So we've got the total number of items divided by the size of each group, and that is going to give us the, the number of groups. And then down here we can flip it because they're inverse operations. The missing factor here stands for the number of groups, and you multiply that by the size of each group to get the total number of items. Okay, so you're going to want to draw a picture that has empty boxes, and you're going to do a count by. So you're going to draw one empty box and do a count by strategy. So fill it with 7 jars. That's just 7 sticks or 7 circles. Okay, and then you start the next box and you count starting at 8. So you'll go 8, 9, 10, and you'll put 7 more jars in that box, and you'll stop counting when you get to the total of 21. Once you get to 21, you should have a certain number of boxes, and that's how many groups you have. And then when it asks you what is the meaning of the unknown factor and quotient, okay, they look like different things, right? Unknown factor and quotient. It's like they're trying to get you to explain two different things. They're the same thing. Okay, I just now talked about what those things stand for. So if you didn't hear me or you don't understand yet, put the video back like a minute or so, and I said exactly what those things stand for. But I want you to start putting it together for yourself. We've got 3 basic parts to these problems. We've got a total, we've got the number of groups, and we've got the size of each group. It's one of those 3 things. Okay. Um, Next, we've got the teacher gives the equation 4 times blank equals 12. Charlie finds the answer by writing and solving 12 divided by 4 equals blank. Explain why Charlie's method works. Okay, so Charlie didn't like having this missing part in the middle of the problem, right? He, he or she wanted to make it so that the answer, so that uh, they could do a division problem and end up with the answer. Okay, so if you've been listening, these division problems and multiplication problems are related. They all have the same parts. So if you've got a missing factor here, you can flip the factor into a division problem and make it the quotient of a division problem. I'm going to let you describe how Charlie's method works on your own, using your own words. This is one of the hardest things to do in math, explaining your reasoning. Okay, it is a hard thing to do, especially for 7 and 8 and 9-year-old kids. It's something that takes a lot of practice. So might as well start now. You've got today to work on it, and we will work on it much more as we go through the year. Okay, the last one is confusing. The blanks in problem 5 represent the size of the groups. Okay, they're telling us straight up, this means the size, what we're trying to find is the size of the group. So they're not giving us things to think about. They're not telling us about tennis balls or jars of tomato sauce. This is just math talk. So we've talked about the 3 parts of a multiplication problem and the 3 parts of a division problem, and it's asking us to draw an array to represent this equation. So once you figure out this number here, you should be able to know that you've got, if 5 represents the size of the group, that would mean 4 represents the number of groups, okay? And so you should have 12 total items, and you're going to arrange them in an array. All right, I'm out of time for my video. If you get finished and have extra time on your hands, repetitions in math make you a master. Good luck. You can go on to the lesson 6 homework if you get the chance.